Hello, welcome back. We're still working on, which section was it? It was the solving section, right? And it was 7.5. And we had this problem 44, and I had said, do only one. And so, and I said that I probably wouldn't be able to resist doing all of them because that's how I am. I'm going to start with C because it's the easiest one. And so it says, C says f at x equals negative g at x. So f at x is 4 over x plus 2, using our function notation from chapter 6. And then g at x is 4 over x minus 2, but remember it has negative here, so it's negative of that fraction 4 over x minus 2. Then I want to solve this. That's what they're asking me to do, is find x, so solve for x. And how I would solve that for x is first to get rid of the fraction. And how you're going to get rid of the fraction is by finding the common denominator, which is by factoring the denominators. So this is x plus 2, doesn't factor. X minus 2 doesn't factor. So the lowest common denominator is x plus 2, x minus 2. My computer is going crazy because my calculus students have something due here in 3 minutes. And so it's now bling, bling, blinging. And so I'm going to multiply this fraction and that fraction by it. So, and it doesn't matter which side of that I write it on the left or on the right. So I'm going to multiply by x plus 2, x minus 2, and the same over here, times x plus 2, x minus 2. And I'm here, this is over 1, I'm here to cancel. This is over 1, I'm here to cancel. And so the x plus 2 reduces with the x plus 2, and leaves, and I would write it as the monomial 4 times x minus 2 equals, and then the x minus 2 reduces with the x minus 2 and leaves the minus 4 with the x plus 2. And then you would solve that normally. And so when you solve this, you're going to get 4x minus 8 equals, and then negative 4x minus 8. And if I'm solving that, I would, it was fraction, right? And so I cleared the fraction. And now I'm on, oh, it's linear. And so you would add 4x to both sides and add 8 to both sides. So I get 8x equals 0, and I'm going to divide and divide by 8 to solve for x, and I get x equals 0 divided by 8 is 0. And I would want to check my answer. So my original equation was 4 over x plus 2 equals negative 4 over x minus 2. So if you put in 0 for those x's, you're going to get 0 plus 2 equals negative 4 over 0 minus 2. And I want to check, does the left side equal the right side? So this is 4 over 2, which is 2, and of course you could use your calculator. And this is negative 4 over negative 2, which is also 2. And so we solved it. The answer is 0. And so that was 44, part C. We'll give a try here also, can't help myself, to 44, part A. So f at x minus g at x equals negative 4/3. So what we're going to be putting in for f at x is 4 over x plus 2. Minus, and what we're going to be putting in for g of x is 4 over x minus 2 equals negative 4/3. And then I would want to get a common denominator, and this doesn't factor, and 3 is doesn't factor either. I wouldn't probably put I put the parentheses around the binomials to remind me, hey, that's one piece. So the lowest common denominator, I always like to name the monomials first, is a 3, and an x plus 2, and an x minus 2. And that's what I'm going to be multiplying all 3 of these pieces by. I'm going to go and multiply by that lowest common denominator, and the x plus 2 is going to drop. By the common denominator, and the x minus 2 is going to drop. By the lowest common denominator, and the 3 is going to drop. So that's going to be my plan and how I'm going to go here. So, and it doesn't matter which side of the that you write it on. So I'm going to give myself some space here. And so when I multiply times, it doesn't matter if I write this on the left or the right, 3 times x plus 2, x minus 2 over 1, and then minus and 4 over x minus 2, and then I'm going to multiply that by 3 times x plus 2, x minus 2, and then equals negative 4 over 3, and then times every single one of them, 3 times, because of the distributive property. And I'm here to cancel, right? And this is over 1. This is over 1. And the x plus 2 cancels with the x plus 2. And what that leaves is this stuff left over that I need to multiply together. And I can multiply the 4 and the 3 together really good with my head. That's 12. And then times x minus 2. And then here the x minus 2 cancels with the x minus 2. And I can multiply together really good, the 4 and the 3 together, that's 12. And remember I have minus. Minus 12. And then x plus 2. I have that x plus 2 as well, right? And then on the other side over there, the 3 cancels. And so that gives me a monomial, minus 4. And then I have this binomial times that binomial that didn't reduce or cancel. And now, this is my new thing to solve. So I was up here saying, oh, there's fractions. Got to clear the fractions, find the common denominator. And now I'm looking at this and thinking, is that linear or is that quadratic? I can see it has no fractions. And so, but is it linear or is it quadratic? And so right here, if I was to multiply that back together, that'd only be 12x minus 24, and etc. So that's not x to the second. But look right here, x times x is x to the second. So I know it's going to be quadratic. So I'm going to multiply this together so I can get 0 on one side. So even if it was linear, I'd be saying to you, I'm going to multiply this together. So we're going to have here 12x minus 24 minus 12x minus 24 equals, and then I can't multiply 3 things together at one time, and so I'm going to choose to multiply these together and then distribute the negative 4. So I'm going to have minus 4, and I'm going to multiply this together. Now I know when I multiply this together that when I FOIL it, that the outer and the inner are going to make 0. So I'm just going to be lazy and multiply the first and the last. So this is going to give me x squared, and this is going to give me minus 4. And so when I multiply this together, I'm going to have negative 4x squared plus 16. And on the other side, I might as well combine the like terms and put it down here. So I have 12x minus 12x is 0, and negative 24 and negative 24 is negative 48. And so now I'm going to try to solve this equation here, and I'm all, oh, it's degree 2. When you have degree 2, you want to get 0 on one side. And I like, because I'm going to have to factor, to have my lead term to be positive. So there's my leader right there, and my leader is negative. So I'm going to make this side be the 0 side. So I'm going to add 4x squared to both sides. So plus 4x squared. And I'm going to take away 16, right? So that gets 0. And take away 16. Take away 16. So that this side becomes 0. And this side is 48 and 16. So I'm going to add that with my calculator. They're both negative, so I really am adding. And it's going to be a negative 64. Okay, so this is 4x squared minus 64. After you get 0 on one side with your leader being positive, like it is, then what you want to do is you want to factor. So you want to whip out your F word, factor. And when you have a binomial, you start with the greatest common factor. And the greatest common factor here is 4. So I'm going to pull out a 4. Let's see, 4 goes in there 16 times. Equals 0. And then that's a difference of squares. So I factor it like my friend, that's my best friend, the difference of squares. And so now what I want to do is I want to set the pieces equal to 0 and solve. So it's silly to set 4 to equal 0 because 4 never equals 0. So really that gets ignored. But here's where things could change because it's a variable. X plus 4 could equal 0. That's when we're at negative 4, right? X is negative 4 is our answer. So we had degree 2 and this is degree 1. And you solve it normally, which is get them separated. And then we have this other solution, which is also degree 1, linear, and all you have to do is get it separated. All you have to do is add 4. So we have our answers 4 and negative 4. And you have to check, you have to make sure that it works back in the original equation. And so it's a must check. Will I run out of room? Well, I could just start on a different piece of paper already and not have the stress of running out of room. And you have to check in the original. So that's 4 over the blank plus 2 minus 4 over the blank minus 2 equals negative 4/3. And I'm going to check these one at a time. I'm going to be putting in here negative 4. So I'm going to put that in my calculator and see, does that equal negative 4/3? So the fraction 4 downstairs, parentheses if you like. Parentheses are not necessary, but if you're like, I'm writing it exactly the way I have it, you can. Definitely your calculator knows. I don't think it laughs at you or anything like that when you put in parentheses that weren't necessary. It only laughs at you when you don't put in parentheses that were necessary. And so when I do that, I get negative 4/3. Using my calculator equals negative 4/3. And so that means that x equals negative 4 was a good solution. Now I want to go check 4. So the same way, I'm going to check 4. So when I put in 4 here, the good news is I already have that on my screen. And I did put the parentheses, so that alerts me to where I had the substitution. And so I just hit the backup key and I'm just backing up and I'm going to delete that negative. So I got right there. And sometimes I make a mistake and I delete the thing I didn't want to delete, but I've kind of learned that you have to be right after it and you hit delete and it backs up over it. And so now I've got exactly what I was wanting to have here, right? Putting in the 4. And into that equation, and I'm hoping that's going to equal negative 4/3, and it does. If it doesn't equal negative 4/3, then I've made a mistake. If it equals math error, then that means that you had 0 in your denominator and it's an extraneous solution, which it didn't. You always have to check these. And so if it equals something other than negative 4/3, I made a mistake. If it equals math error, then that means it was an extraneous solution that really made the original equation's denominator equal 0. Okay, woo, those are long, right? I mean, that seems so, would you like to do all 3? Do only 1. And I think I let my class last semester choose. And here I am boring you with all of them. but maybe you take it as an example. It certainly has practice of everything we've done so far in the class, and so that's the good news or the bad news or whatever have you, is practicing, right? So g of x is equal to 4 over x minus 2. So I'm replacing in, this is my main fraction bar, right? Now I'm going to go put in what f of x is, which was 4 over x plus 2 equals negative 7. And this is a complex fraction, and it's, it's not simplified. So I think what I would do is start off by ignoring the negative 7 over there and just simplify this and then solve it. I mean, that's a way of going, certainly. And so that's going to be my plan. And because this is one fraction over one fraction, what I'm going to think here on simplifying that side is that this is 4 over x minus 2, and then divided by 4 over x plus 2. And then I'm going to turn that into a multiply. People can do that in one step and flip it here. And I'm just working on that side. So I'm just working on this side. So this really still equals negative 7. And you notice the 4's drop out. So we're left with x plus 2 over x minus 2 equals negative 7, right? So this was just me working that side to make it look better. You have to admit that this looks bad compared to that, compared to what I got now. And now I want to clear the fraction, because I notice, oh, fraction, I got to solve it. And how you clear the fraction is you multiply by the denominator, or the common denominator. I only have one denominator, so I multiply by x minus 2. So I'm going to multiply the lowest common denominator. I only have one denominator, is x minus 2. And I'm going to multiply by it right here. And when the dust clears, you get x plus 2 equals, and then you distribute, negative 7x plus 14. And then now I'm all, oh, it's not fractions anymore. I got rid of the fractions. Yay. Now it's degree 1. And degree 1, linear, you got to get them separated. So I'm going to get the x's on one side and the non-x's on the other. So I'm thinking about adding 7x and taking away 2. And when the dust clears here, 1x plus 7x is 8x. And equals, I was thinking 16, because I was thinking, oh, it'll be a nice answer. But I think it's 12. And going to be a fraction as our answer, 12 over 8, which reduces by 4 to 3 over 2, right? Still a nice answer. There's nothing wrong with 3 over 2. 3 over 2 is quite beautiful, in fact. And so now I want to check my answer and make sure that my answer is right. And you should check in the original. So that's going to be a trick, but it'll give us some practice on our calculator. So this is, the original was 4 over the blank minus 2, big fraction, 4 over plus 2. And we're going to be putting in 3 over 2. And I think I'll employ that answer key. Remember how I used that answer in the last video? So I put in my calculator 3 over 2, 3 divided by 2. There it is, 3 over 2, and now it's my answer. And now what I'm going to do is I'm going to put in a fraction, and then I want a fraction in the numerator of that fraction. So this numerator, that fraction bar is that fraction bar. And so I want to get a fraction up there in the numerator of a fraction, so I'm going to put it there. So 4, and then I'm going to go downstairs, and I'm going to hit the answer, and I'm going to subtract 2. Then I want to go down here. Oh, I was there. There I am. So my cursor is now in the denominator, and in the denominator I want a fraction. So I'm going to hit the fraction key, and I want 4, and then I'm going to go downstairs, and I want to put in the answer plus 2. And I'm thinking that should be equal to negative 7. And if it's not, I made a mistake. And so since it is, I'm like, hot diggity dog, right? So this is negative 7 when I plug in x equals 3 over 2. Remember, that's what I put in for my answer. And so that means that the answer for the problem is x equals 3 over 2. And we did a lovely job on that one. And so I know what you're thinking. Oh, wow. Oh, wow. That took you 20 minutes to do those 3 problems, and it did. So they're long, I admit, and they take all kinds of math to do. I have one more problem here on the notes that go with that section for solving. And they throw in, hey, draw this graph is what they throw in. And it's something we haven't graphed before, and they're just kind of seeing how we'll go. And so do you guys agree with me that if I start picking points, because that's what I usually do when I'm graphing, is pick a few points, and I don't know what this is going to look like. This is something I've never graphed before, right? So my favorite point is 0. And remember that f at x is a fancy way of saying y. So this is saying y equals 1 over x plus 3. And so if I put in 0, then my y will equal 1 over, so we're plugging in, right? 0. So that would be 1/3. And if I plug in 1, then y will equal 1 over 1 plus 3, which is 1/4. And if I put in 2, I'll get 1/5. Do you guys agree? And if I put in 3, I'll get 1/6. And if I put in 4, I'll get 1/7. And I hope that you're thinking, sitting there thinking to yourself, I don't even know if you can plot all of those. And so I'm gonna, but I'll give a try to seeing how that goes, right? So you certainly might be correct. So like, for example, if I plot the first one, so up 0, up 1/3, that's hardly up at all. And then up over 1, up 1/4, that's hardly up at all. And it's not at quite as much as 1/3. And then it's not quite, 1/5 is not quite as much as 1. And so 1/4 was, and then 3. So I can kind of see that it's getting closer to the x-axis as I go. Ooh, I almost had a symbol going. And so I can kind of see that I've got this going here, right? At least. And you can imagine that if I kept going, am I ever going to get to a point that when I pick a value like 9, am I going to get 0 out of that, or am I going to get a negative out of that? I might ask myself that. And I'm not, right? When I put 9 in, I'm going to get 1 over 9 plus 3, and 9 plus 3 is 12. I'm going to get 1 over 12. And that's so close to the axis that I can't draw it, but it's not getting to 0. And even if I choose 100, I'm going to get 1 over 103, which is not 0 and it's not negative. So that's not going to happen, right? This was 1/12. And so it's going to just kind of continue going on in this fashion, getting closer and closer to that axis. And so I'll just kind of leave it out there trailing off. What typically happens is that people will put a dashed line to show that it's not going to cross through that axis. Okay. Now I might be curious, well, what happens at -1? So let's see what happens at -1. So if I put that into my equation, 1 over -1 plus 3. Now -1 plus 3 is 2, so that's half. So I'm going to plot that. So 1/2. Now half is a little bigger, a little higher than 1/3 was, right there at half. And you might be curious, well, what's going to happen if you pick -2, right? Because I'm kind of seeing what happens here. And so if I do, I get 1 down there, and 1 over 1 is 1. So that is going to be -2, 1. And what if I pick -3? Well, that's 1 over 0. So that's undefined. And so that's not really something that's in the domain. Remember, they were asking us about domain. That's not something I'm allowed to choose. And so what they typically do is they put a dotted line there to show that you're not going to reach that value. And that dotted line is hard to see, I know. And my pins are weak and my body is weak because, boy, this has become a lot today for me. And so if you think it's a lot for you, I agree. And the good news for you is that you can kind of break it up a little. And I'm feeling like I have to go straight through because I have so much calculus stuff to do as well. Okay, so I might be then curious, well, what happens between 2 and between -2 and -3? So I try -2.5 just to see. And now I might be interested in getting my calculator out. If you were already interested in having your calculator, you certainly could have that. So I want to make sure it's on, get a fraction, 1, and then I'm going to put the parentheses that I'm going to be filling in with -2.5. And then I'm going to add 3. And I get 2. So -2.5, I get 2. I'm going to plot it. And then what if I got closer? Like -2.9. So I'm going to go fill in here. And I get 10. So -2.9, that's 7, 8, 9, 10, ... right? And so you can kind of see that it looks like on this side that my graph goes like this. Almost straight up there. Not quite straight up, but it looks almost straight up there. Okay, so we have a lovely drawing of there. This is how a rational expression would look. And now I want to look at, well, the other side. So what if, so we said that it wasn't okay to pick -3, but how about -4? And now that I've got this on my calculator, I think I'll just start putting it in the calculator and using it to do my value. So I get -1. So -4, -1. And I'm going to choose -5. And I get -0.5. So here's -5, -1/2. And I'm going to choose -6. And I get -1/3. So that's even closer. And then you can kind of imagine that same thing happening over here, that I'm going to get closer and closer to the x-axis, but I'm not going to cross the x-axis. It's never going to be 0 as I plot in those points. It's never going to equal, the y value is never going to be 0. If you put in a value here, right, you're never going to get 0. And so what if I got closer to -3? And so things like -3.5. So if I put that in, 3.5, that's at -2. So 3.5 is here, it's at -2. And if I picked -3.1, I get -10 here. And so it kind of does that same thing. So I would really encourage you to go and look at more of the graphing that that they have in the textbook. And so there is the end of this video here. And so I'm not going to do these bonus problems for today because I just think that today's already overwhelming. And so make sure now you give yourself a rest. The governor says that it's okay to have a little walk as long as you're not walking near other people, I guess. I don't know. You decide on that, but I go in your backyard or go somewhere. I get a little sunshine. I was so depressed, and I know that it's a little bit cloudy out there, but it did help. Okay, talk to you later. Bye-bye.